Okay, here we are, 1998 AP Calculus AB exam, section 1A. We do not get a calculator, and we are going to tackle problems 11 through 20. I feel good, good day. Let's do some good math. All right, number 11. If f is a linear function and 0 is less than a, and a is less than b, then the integration from a to b of f double prime of d of x is. All right, well, I have done this time and time before. We have f prime, and we have f double prime. Okay, first, this is a derivative. This is one derivative away. Backward would mean it's integration. So if we're going to integrate f double prime, it should give us f prime, meaning this equation up here will give us f prime from the upper bound minus f prime to the lower bound in there. Okay? So, are you ready? Are you ready? Here's the thing. Linear function. It's a linear function. Okay, if f is a linear function, okay, the slope is a constant. Okay, a line has a slope, meaning right here, let's say the slope is 2. Right here, the slope is 2. Right here, the slope is 2. It is always going to be 2. If f is a line, that means f prime, f prime will always be the same no matter where it is, whether it's point A on the x-axis or point B. It will always have the same value. These will be the same value. Anytime you subtract something from itself, you always get 0. And that is choice A. 12. If f of x is a piecewise function here, when x is between 0 and 2, you use the ln of x. For x between 2 and 4, you use x squared times the ln of 2. Then find the limit of f of x as x approaches 2. All right? Very, very simple. The limit of f of x as x approaches 2 from the left needs to be the same as the limit of f of x as x approaches 2 from the right. All right? If they're not the same, it doesn't exist. Okay? If they are not equal, it doesn't exist. There is no limit. If they are equal, whatever number or value we get is the limit. Okay? Right at 2. All right, well, if I am looking at 2, the numbers to the left are smaller than 2 are this one. Okay, so I'm going to use this. So the limit of ln of x, okay, as x approaches 2 would be the ln of 2. All right. Well, from the right side are the numbers bigger than 2. Okay, we're going to use x squared times ln of 2. So if x squared times the ln of 2. Now, x is approaching 2, so 2 squared ln of 2 would end up being 4 ln of 2. Now, before you start telling me I need a calculator, I don't know what the ln of 2 is. Well, whatever it is, this is the same value here. If I multiply one side by 4, but I do not multiply the other side by 4, there's no way they're equal. Okay? And for some of you that don't understand that, I mean, you should at this level. But if you don't understand that, let me use an algebraic way. Let's divide both sides by the ln of 2. Boom, boom. Divide this by the ln of 2. I now have 1 equals 4. Okay? What is our rule when the variables go bye-bye? Either the numbers are equal and everything works, or the numbers are not equal and nothing works. Since these are not the same, there cannot be a limit at 2. It is non-existent. Stop it now. Stop it. Y'all know how I feel about graphs. I love them. I love them a lot. All right, so let's take a look at 13. The graph of the function f, shown in the figure above, has a vertical tangent line at the point 2, 0. So I'm just going to go ahead and do these things right here. Okay, so there's a vertical tangent line at 2, 0, which is 2, 0 right here. Vertical tangent. It's a vertical tangent line. I'll just put VTAN, vertical tangent line. And a horizontal tangent line's at 1, -1, which will be right here. That's a horizontal tangent line. Okay, and at 3, 1, okay, right here. That's a horizontal tangent line. All right. For what values of x between -2 and 4 is f not differentiable? Okay, so, oh, I get to use my line. So from -2, from this point, all the way to 4 to this point, where can I not take the derivative? Well, let's first point out the obvious, okay? I will do this. Let's do this in orange, okay? If there is a discontinuity, you cannot take the derivative. That happens at the origin where x is 0, okay? You can take the derivative here. My slope or derivative is 0. That's a valid slope. A horizontal line has a valid slope, but a vertical line has a slope that's undefined. My slope or derivative is undefined here. Here my slope is 0. That's good. Here my slope is 0. That's good. I'm using m for slope, like the equation of a line. So at 2 and at 0, okay? I should do this way. When x is 0, x is 2. That's where my function is not differentiable. Love me some graphs. Number 14 is a good question. Even though there's no graph, I'll still do it. A particle moves along the x-axis so that its position at any time t is given by x of t equals t squared minus 6t plus 5. For what value of t is the velocity of the particle 0? If you have position, velocity is the derivative. So where is the derivative? 0. Okay, you have position, you have velocity, you have acceleration. One derivative away, okay? So I'm going to take the derivative of position to get velocity. Velocity equals the derivative of position, okay? Derivative of that is 2t. The derivative of the next term is minus 6. The derivative of any constant is 0. That goes bye-bye. Okay, so velocity, this is velocity. When, meaning at what time, is this equal to 0? Isn't 6 minus 6 0? So t should have to be 3, okay? But for all of you that want to see the algebra, I'm going to add 6 to both sides and get 2t equals 6. Then I'm going to divide by 2. Okay, so t equals 3. There you go. A lot of the problems in the section that you don't get a calculator are very, very easily doable once you set them up. The key is setting them up. 15. Oh, again, no graph. But you know what? Another simple one as long as you set it up right. If f of x equals the integral from 0 to x of the square root of t cubed plus 1, then f prime of 2 is what? I could have sworn that earlier on this test, and let me take a look, let me think about when this is. Maybe it wasn't this test. It was not this test. We've done something before Well, yes, number 5. Number 5 had a similar situation. Okay, if you go back to my video for this test, 1998, questions 1 through 10, number 5 had a situation like this, and I said, don't take the derivative of this. They weren't asking. They just had this, something like this, and they said, just integrate that. And a lot of people, because you have a different variable here, just want to substitute the variable, get rid of the integral, like I was taking the derivative of an integral. Okay? In that problem, I had to actually integrate and plug an x in for my upper bound. But right here, okay, in case you haven't picked up on this, let's go with this light blue. That's nice. If f of x is the integration from 0 to x, the square, yeah, that's a square root of t cubed plus 1 dt, and they're asking you for f prime at 2. Well, if I'm going to take the derivative of f to get f prime, right? I also got to take the derivative of the other side. So this problem is asking you to take the derivative of an integral. Okay? What you had to fight the urge to do in problem 5, you have to do for problem 15. And when I take the derivative of an integral, they're like opposites. This goes bye-bye. The dummy variable goes away with the integral. And this variable here just gets substituted in. So it ends up being the cubed root of x, yeah, the square root of x cubed plus 1. And I want this at an x value of 2. Okay, at x equals 2. I told you the math is real easy. So it is 2 cubed plus 1. That's 8 plus 1, which is 9. And that answer, wow, a lot of 3s today. A lot of 3s today. All right? We're doing good. We're doing good. 16. If f of x equals the sine of e to the negative x, then f prime of x is. All right, let's go. We're just taking the derivative of this expression. There's no value for x, so we'll have an expression as an answer. Chain rule. I'm going to take the derivative of this, okay, and that will go there. The inside will stay the same. This won't change, okay? So the derivative of sine is cosine of e to the negative x. Now, what the chain rule tells me is at this point, I multiply it times the derivative of the inside, okay? The derivative of e to the negative x is always, we always start out by just rewriting it, e to the negative x times the derivative of whatever the exponent is, which is negative 1. All right, so let's make this all nice and neat. This will end up being negative e to the negative x, and they always put constants in front of trigonometry. So then I got cosine of e to the negative x. This would follow it. That's it. It's that simple. Okay? So as I look at my answers, it looks like there's only one answer that has a negative e to the negative x out front. And that happens to be the whole correct answer, which is choice E. Guys and girls, people, if you will, I'm going to try not to get too excited because we have a graph. Oh my God. Here we go. Number 17 says, the graph of a twice differentiable function f is shown in the figure above. So right now I know that this is f. It is not f prime. It is not f double prime. That is the graph of f. Which one of the following is true? And if you look at this, every single answer here compares f to its derivative to its second derivative. f to the second derivative to the first derivative, so forth. So we're always looking at f, f prime, and f double prime, okay? And all of these are at 1. 1, 1, 1, 1. I mean, I could do this forever, kids. I like playing with highlighters. It's fun. So I need to find, well, what's f of 1? Okay, I need to find f prime of 1, and I need to find f double prime of 1. Okay, well, I might not be able to get an exact number for most of these, but I can look at it and figure something about each one of these. First of all, this is a coordinate, x, y. This coordinate right here is at 1, 0. So this is 0. So f of 1 is 0. Okay? F prime of 1 is the slope. Okay, so this is the slope. The derivative is a slope at 1. This looks like a positive slope to me. I don't know what it is exactly, but I know it's positive. And if I look at my answers, I'm comparing them in an inequality. So the smallest value is listed first. The middle value is listed next. And the largest or biggest value is listed here. So I'm really comparing. And right now, anything that's positive is definitely bigger than 0. So right now, I need to find f prime is bigger than f of 1. Okay, so here, f prime is bigger than f of 1. That's good. Okay, f prime is bigger than f of 1. That's good. F prime is small. This one, it's not this one. Can't be that one. Okay. F prime is bigger than f of 1. Good. F prime is smaller. It can't be this one either. I mean, we could have just figured out double prime and done it, but we're just going to eliminate some answers here. Okay, so f double prime, that's the second derivative. That's concavity. That means it's either a smiley face if it's positive or a sad face if it's negative. All right? This right here at 1 is definitely a sad face. Okay, it's going like that. So that's negative. So if I were to list these from smallest to biggest, the negative value is smaller than 0. So it's a f double prime first. Then 0 is smaller than a positive, so I'd lift f next. And positive is the biggest. It's bigger than a negative or 0. So it should look like this. F double prime, F, then F prime. F double prime, F, then F prime. Choice D. Can't be those. 18. That's a good old-fashioned calculus question right there. I mean, we said, what was this, 24-year-old test? I like this one. Right, so number 18, an equation of a line tangent. Okay, anytime, I'm going to get my fancy pen, fancy pants. Okay, anytime I have the equation of a line tangent, I should immediately start with my equation of a line for calculus. But mister, look, they're all y equals. I don't know. Well, big deal. Put all the numbers in here. Then get this y alone. Add y1 to both sides. If you want to do that now, you can. If I wanted to add y1 to both sides, now I could. So look at, y equals that. Then you just combine everything on the right side. But for the sake of confusion, let's start with this. We'll put the numbers there first. And then we'll move it over. Okay? So what's beautiful here, and every time I tell my class about these types of problems, they'll either give you an x, and you need to find a y, or they give you an x and a y. These are my x1 and y1s. The most work for these type of problems is finding the slope, because the slope is the same thing as derivative. Let's plug in our x1 and our y1. So y minus y1, which is 1, equals, I still don't know the slope, okay, times x minus x1, which is 0. Okay, that's nice. That's going to just end up being y minus 1 equals slope times x. Okay, because x minus 0 is x. Now, slope is the same thing as derivative, or in this case, y prime. Okay, the derivative of x is 1. The derivative of cosine of x is negative sine of x. All right? I want this at an x value of 0. So I've got 1 minus the sine of 0. Oh, I've said this before. You are going to need to know the sine, cosine of 0, 90, which is pi over 2 in radians, 180, which is pi, 270, which is 3 pi over 2, and 360, which is 2 pi. You're also going to need to know 30, 45, and 60, okay, those special triangles. I like referring to the graph. Sine is that fancy S. Woo, woo. Here is 0 degrees. Here's 90, or pi over 2. Right here is pi. This is 3 pi over 2, and here's 2 pi. Okay, that's a bad pi. At 0 degrees, my sine is 0, because here's 1, here's negative 1. So 0. The sine of 0 is 0. 1. That's my derivative, which is my slope. Let's put that in right here. All right, so y minus 1 equals x. Just add 1 to both sides. So you see, you were worrying, and you're like, Visca's not the same. Just add 1 to both sides, you little nervous Nelly. So I got y equals x plus 1. And if I look at all of my answers, that is choice B, you nervous Nelly. Trust me. Sometimes you got to trust me. It's a tough thing, trust. Because if I ever break it, if I break your trust, you ain't never going to trust me again. I hope I don't break your trust. Wow, I just put a lot of pressure on myself right there. Let's move forward. 19. All right. All right. 19. If f double prime equals x times x plus 1 times x minus 2 squared, then the graph of f has inflection points where x is equal. All right? Where x is equal to. First of all, I'm going to get my cool pen. And let's go orange. I think, I should use pink, but I don't know how that's going to come out in the video. Let's use a soft green. How about that? How about that? I'm going to solve each one of these for 0, okay? So here, the first one, x equals 0. For the second one, x equals negative 1. And for the third one here, okay, x would equal a positive 2. Okay, those make these, all those values make what's in there 0. Putting a negative 1 in for x makes this 0. Putting a 0 in for x makes this 0. So, what is the significance for the zeros of the second derivative? Those are all the places where you might have an inflection point, because that's where the second derivative is 0. But we got to do something else, okay? So here's 0. Here's negative 1. Here's 2. All right. So what I need to do is I need to pick values in between. Okay, let's pick 1, 3, 1/2, and negative 2. Okay, here's where my second derivative is equal to 0. Yep, I'll be okay. Boop. Oh. Second derivative is equal to 0. Here, here, and here. So I want to see if I got pluses and minuses. I need my sign, either positive or negative, to change around those zeros. That's where an inflection point happens. Let's start with 3. If I throw a 3 into the second derivative, I get a positive 3, a positive 4, and a positive 2. Okay, all I'm doing is I'm positive 1. Okay, if I put a 3 here, that's 4. If I put a 3 here, that's obviously... If I multiply 3 positive numbers together, I still get a positive value. So this is positive. All right? So I'm going to do that. I'm going to rewrite this here. Okay, I'm going to do that for all of these numbers that I have in blacking. Let's try 1. Okay, if I put a 1 here, I get -1, but let's not forget I'm squaring it. So it still ends up being a positive. This will always be positive because I'm squaring it. So I'm not even going to check the number there. That will always be positive. If I put a 1 here, that's a +2. If I put a 1 here, it's a +1. If I multiply 3 positives, I still get a positive. This is not an inflection point because the signs don't change around it. All right, let's try 0. 0, 0, 0, 0. Okay. Well, I'm not going to try 0. We already know that's a 0. I'm going to try 0.5. All right, how about we do that? How about that? Okay, 0.5. And by 0.5, I mean -0.5. Someone might have caught that earlier. See, that's that trust. I almost lost it right there. Okay, between 0 and -1 is -0.5. So let's do that. Well, it doesn't matter. This will always be positive. Okay, if I put a -0.5 here, that will still give me a positive 0.5. So I have a positive here. But guess what? This will be -0.5. If I multiply a negative times a positive, I will get a negative. This right here is a negative value. So this is an inflection point. So my answer has to have 0 in it. Good. Nope. Good. Nope. Nope. So it's either C or E, but guess what? 2 is not in there. Nope. Nope. Here you go. So guess what? If I put this number in here, it would probably be positive because I would end up with a negative for here, for -2. If I put a -2 in here, I end up with a -1. Okay? A negative times a negative would give me a positive. Okay? So this is also an inflection point. 0 and -1. Now, if you were kind of confused with me just looking at the positives and negatives and then multiplying, you can put the number in there and figure out what the number is going to be. You sure? And you would end up with a positive product or a negative product. But the number isn't important. It's the sign of that number, whether it's positive or negative. Number 20. What are all values of k for which the integration from -3 to k of x squared dx is equal to 0? You have to do no math here whatsoever. There is a rule, okay? When the lower bound is equal to the upper bound, your integration is 0. So when the lower bound is equal to the upper bound, there you go. What's the value of k? -3. You're welcome. That was a great one to end with, okay? If you wanted, okay, and there would have been people, especially in my class, they would have said, okay, the integration of x squared is x cubed over 3. I want that from k to -3. And they would have done this math. They would have said k cubed over 3 minus -3 cubed over 3. And they would have set it equal to 0. They would have done that. And you could get there that way. But we're smart. That's me keeping your trust, even though I almost left that 1/2 positive in the last problem, and it was negative. I caught it. I caught it. We are done. We are under 30 minutes. I love it. It's fantastic. Ring the bell. Give me a like. Show me some love. Just show me a little love. I need love. I need love like everybody else does. And follow me. Why is it important to follow me? Because when I continue this and I put up the new video, you will get a notification. Bing, bang, boom. I don't know if that's your notification sound, but it would be really cool if you took this audio, spliced that out, and used that as your new audio for notifications. Patent pending, patent pending. I'll see ya. Ring the bell, like, follow me. I'll see you for problems 21 through 30. Sweet.